All right, we are so close to being done with this challenge. All right, we still have a few more resources that we need to create. So if you look at our main.tf file, you can see that we have a public route table, and then the public route table is associated with a subnet, and we have an internet gateway that allows all of these pieces to connect, right? So that is why we are able to connect to and make requests to the internet and have the internet make requests to our public EC2 instance, all right? But if you remember in the first challenge, we also needed a gateway so that way the private instance can still download and install and communicate, like contact the internet in order to load our application on it. All right, so we need to set up a NAT gateway for that. All right, so what I'm going to do is I'm going to go to Terraform NAT Gateway, and I'm going to look at how we do it. And if you look, you can see this example here for a public NAT, which is what we want because we want to be able to have our private instance communicate with the internet. All right, so we want this here. So I'm going to copy it over and I'm going to put it right under my public subnet information. All right, so now you can see that we have AWS NAT Gateway, and then we are going to call it Gateway NAT. All right, you can see then it's referencing two other resources. It's referencing a subnet ID, all right, which we need. So we're going to say AWS underscore subnet dot, and then we could either choose the public or the private. Now, ultimately, the NAT gateway is opening up a one-way gate to the internet, so we want it to be in our public subnet. All right, then we need to write .id. All right, because we're looking for the subnet ID. So now you can see that the white goes away, which means we have this resource. All right, I'm going to change the name of it to Coding with Callie NAT Gateway. Let me see what I named the, yeah. Sure, we'll do it like that. So now we have that part. That's good. We still need to figure out what this allocation ID is. So let's go ahead and scroll down to try to figure out what's going on. Oh, okay. So the allocation ID is going to be the ID of the elastic IP address, which is required to connect publicly. All right. So we are trying to connect publicly. So, and because that's what connectivity type defaults to, you can see we don't have the property for connectivity type, so it's defaulting to private, and we want it to be private, so we need to create an elastic IP address. All right, the last part of this is that we want to ensure proper ordering. So we want the internet gateway to be created first and then the NAT gateway, because the NAT gateway is ultimately going to use the internet gateway to get out. Okay, so it's going to depend on AWS underscore internet gateway dot gateway. All right, and then I'm going to get rid of those comments. All right, so we are close, but this we do not have. So we have to create it. So I am going to go to elastic IP address AWS. And I'm going to try to look. So AWS EIP Terraform. Here we go. All right. A single elastic IP associated with an instance. All right, so we don't want it associated with an instance. All right, so this is creating a VPC, an internet gateway, a subnet, an EC2 instance, and then an elastic IP address. So we can add that it's dependent on the internet gateway. That's fine. Domain. Not really sure what the domain line is for. And we don't need those. So I'm curious if all we need is, okay, domain indicates if this EIP is used is for use in VPC. Instance is optional. Okay, Boolean if EIP is in VPC or not. Use domain instead. Defaults to true. All right, so we don't need to actually use domain or VPC because the default is true. So it looks like the only thing that we really need to include then, so I'm gonna put that down, and then I'm gonna say resource. Sure, we can add it even though it defaults it to it. And what do we need to do? We need to have a depends on, and it's gonna depend on our internet gateway. All right. I don't see any tags here. Okay, so it looks like tags is an optional thing. I'm not going to worry about it. And I'm going to, see how that works. And then now let's change this from example to, we are going to change it to, what do we want to call it? NAT, that works. All right. So then instead of AWS underscore EIP dot example, we're going to have .NAT ID. And hopefully this sets up our NAT gateway. All right, but as we talked about before, we still need to do the public route table and the route table association, or the private route table and the private route table association. So I'm going to go ahead and copy that and paste it down here and hope I don't get this wrong as I'm going through it. So I'm going to go line by line. All right, so we want to create an AWS route table. We're going to call it the private route table. It will be in this VPC. And what route do we need? So CIDR block. So this is going to be all. And then gateway ID is going to not be our internet gateway. Our gateway ID is going to be our NAT. I'm going to try to type it out to make sure I can remember this. .gateway underscore NAT.id. Okay, so that's going to be our gateway ID. So that's the route that we want. We want the NAT gateway to be able to communicate with the internet on all IP addresses. All right, and then we have our tags, and we're going to switch this from public route table to private route table. Perfect. The next one's our route table association. So we want to associate our private route table. We want to create our private subnet association. So the subnet ID is going to be the private subnet ID. And then the route table ID is going to be the private route table ID. All right. And hopefully this is everything that we need to add. So I'm going to go ahead and do Terraform apply and see how we do. All right, so we're going to add 4, which makes sense because we made 4 things. We made the private subnet association, the private route table, the NAT gateway, and the elastic IP address for the NAT gateway. I'm going to say yes. I probably could have been better by scrolling through and actually verifying that it was saying the right things, but might as well chance it. All right, it's creating. All right, so while we wait for that, we're going to go over to our instances. We're going to go to our Bastion host, and we're going to go to connect. And I'm going to copy my EC2 user here. So I'm going to get ready because I'm going to SSH into my EC2 user. And then I'm going to try to SSH into my, what's it called? My private instance. I also forgot my SSH command already. So I remember though this, and I'm going to bookmark it now. And so now I know I can add it with just SSH add. So the gateway is taking a little while, so I'll go ahead and pause and then I'll start back up when we're ready. All right, yay! Our resources are created. So now I'm going to do SSH-add, and then I think it's coding with Kali key.pem. All right, warning, unprotected private file. My permissions are too open. All right, I will need to look into that at some point, but just make sure while you're playing around with this, it's probably not the best idea to go ahead and commit all of this to GitHub. So make sure you're doing adding a get ignore file and ignoring things like your Terraform, all of your state, your lock, your PEM key, your state, and your backup. So that way you are not committing any sensitive data. Okay. So then the next thing that we're going to do is SSH into the bastion host, which I did not. All right, so we need to do our chmod first because it's a new key. And then we need SSH-A anyway. Nope, SSH-A. And then I need to recopy and paste it in. Permission denied. All right, let's take a look. Bastion host. We have a public IP address. We're using the public subnet. Let's look at our security. That should work. Let's go ahead and let's connect with just the normal SSH command. All right, so that works. So our SSH add seems to be the issue. So let's look at this SSH add, and then we want to add coding with Kali -key.pem. Couldn't open a connection to your authentication agent. So let's go ahead and check if our authentication agent is running. This really goes to show you too how important it is to okay, so we're getting different error messages, so that's something. No file. Oh, because I'm in my user. This is so silly. Okay. All right, so I'm in there. Okay, but if I do now, let me. Okay, so then SSH-add coding with Kali-p.pem. Okay, identity added. So then we want to do SSH-A and then paste in not that. And let's go back and get the correct address that we're SSHing into. All right, so now we're SSHing into the bastion host and we're forwarding. So that way we should be able to now hopefully SSH into our private EC2 instance, which we were able to do before, but we weren't able to download anything once we did it. All right, so now let's go ahead and we want to install NGINX. Let me see if I can just remember the commands. So I'm going to say sudo yum install NGINX. Are we doing it? Are we connecting to the internet? I hope. Oh, yay! And we were able to install NGINX. So I'm going to go ahead and click that yes, that is okay. And this shows you that the NAT Gateway works as intended. So I'm going to end the video here. And in the next one, we're going to get our NGINX installed. See you in the next one.